Alright, this is the intermediate 2 notes, probability, statistics, and data. Just to remind you how to find the average. Typically, unless it says a different type of average, average implies the mean. To find the mean, you sum up all the numbers and you divide by how many numbers you have. So first example. Over a 5-day period, the average high temperature for Cleveland was 30 degrees. If the high temperature recorded for the first 4 of those days were 26, 32, 24, and 35 degrees, what was the high temperature recorded on the 5th day? So once again, to find the mean, you sum up all the numbers and divide by how many numbers you have. We're told that the average high temperature was 30. We're told the number of days was 5. And we're told that one of those days was 26, another was 32, another was 24, another was 35, but we don't know the 5th day. So once again, we know that if we add up all the temperatures and divide by how many temperatures we have, we're going to get the average. We have 4 of the temperatures, we don't know the 5th. So this is the equation that we're going to use, and then we're trying to simplify this equation. If we were to add 26 and 32 and 24 and 35, we get 117. Trying to solve the equation for x, if we multiply both sides of the equation by 5, we get 150 equals 117 plus x. And if we subtract 117 from both sides, we're going to get that the temperature of the 5th day would be 33 degrees. Number 2, very similar. The average score of IV's basketball team for 4 games is 90. So mean equals sum of all the scores divided by the number of scores. 3 of those scores were 89, 92, and 94. What was the 4th score? So the average is 90. In the games, they scored 89, 92, and 94. We don't know how many they scored in the last game, so we'll call that x. It's an unknown, it's a variable. 4 games total. So, if we simplify this, 89 plus 92 plus 94 is 275. If we multiply both sides by 4, trying to get rid of this fraction, trying to get x by itself, we're going to get 360 equals 275 plus x. If we subtract 275 from both sides, we get that the 4th game must have been 85 points. I'll give you another way to look at this problem that may be faster than what we just did there. So we're going to set the bar here at 90. That's what we want to average. One of those games was in 89, which is just the one below. Another game was in 92, which is 2 above. So right now, we are 2 above and 1 below. So if we wanted to even this out, we need another one to be 1 below to average 90. The next game is a 94. So if you look at this one here, we are down 1. These two, we are up 6. I want those to be equal. So to be equal, we need to be down 5 more here. So down 5 below 90 would be an 85. It's another way to look at average if that's helpful. Maybe it is. Maybe it isn't. The average of 8 numbers is 9. So mean equals sum of all the numbers divided by how many numbers do we have. The average of the 8 numbers, mean, is 9. There are 8 numbers. We don't know what the sum is. If one of these numbers is removed from the group, the average of the remaining numbers is 7. So if we take a number out so that we only have 7 numbers, the average is 7, and we don't know what that sum is still. So what we can do is we can take this first equation we have, multiply both sides by 8, and we get 72 as the sum. We have all 8 numbers, the sum is 72. If we do the same thing for this other one here, multiply both sides by 7, we get the sum of 7 of the numbers is 49. So that must mean that the missing number is 72 minus 49, which is 23. So you can recheck that to make sure that it works. If we, well, there's no need to recheck it. Just reread the question. The average of 8 numbers is 9. So we're adding 8 numbers, average is 9. If 1 is removed, so now we have 7 numbers, the average of the remaining numbers is 7. What is the value of the number removed? Yeah, it's got to be 23. Probability of a single event. The probability of something happening is the number of favorable outcomes divided by the total number of outcomes. Example, a 6-sided die is tossed. What is the probability that you will get a number greater than 6? So probability of a number greater than 4. Well, how many outcomes are there greater than 4 on a die? There are 2. You can have a 5 or you can have a 6. You divide it by the total number of outcomes. There are 6 sides to a die, so the probability of getting something greater than a 4 is 1 out of 3, because 2 6 reduces to 1/3. Next we have the counting method. A litter, if you will, has 4 black and 5 white kittens. And how many ways can a pair of 1 black and 1 white kitten be chosen from this litter of kittens? So here's how the counting method works. We got 2 choices. We're going to multiply those 2 choices together. So we have 4 black cats to choose from. So how many choices do we have? We have 4. Could be any one of those 4. We have 5 white kittens to choose from in this scenario. Simply multiply those together, and that is how many ways pairs of kittens can be chosen. If one of them has to be black and one of them has to be white. 20 different ways. Another example. From a garden warfare, there are 6 different types of flowers. If a bouquet of 3 different types of flowers are to be chosen, how many different possible bouquets are possible? Notice it also says that 3 different types are going to be chosen. So once again, we're choosing 3. Before we were choosing 2 kittens, we are choosing 3 different types of flowers. Since there are 6 different types, when you choose this first flower, you have 6 to choose from. Now there are 5 different kinds of flowers remaining, because it says we need different types. You can't have the same type twice. When you get to the second choice, you're choosing one of the 5, so there's 5 choices. Once you remove that choice as a possibility, there are 4 choices left. Simply multiply those together. There's a possibility of 120 different bouquets possible.